Question we have force of 2i cap plus 3j cap plus 4k cap acts on a body and displace it by then the work done by this s is 2i plus 3i plus 2j plus 5k cap. So the work done by this force is question asking you the work done by this force will be what? So in this question, okay, simply you need to do dot product of f dot s, you will get the value of work. F dot s, if you do f dot s, you will get the dot product of, after dot product, you will get the value of work. You need to take care of one thing is that, okay, when you do dot product now, so just simply multiply. Suppose we are multiplying 2 into 3, 3 into 2 with sign, okay, 4 into 5, you'll get this answer. So work is what? F dot s. Work is f dot s. So answer will come 32 Joule. Next questions, we are moving ahead. A roller is pulled at an angle of 60 degree to the horizontal through a distance and work done is W. When the same roller is pulled at 30 degree on the same ground through the same distance, the work done is, okay. So options we have W, 2W, W root 3 and W by root 3. So in this question, how to approach the questions? If you see the questions, basically what's happening, there is a roller and you are applying the force by an angle of 60 degree. Okay. So when you are applying the force of 60 degree F, so this is what F cos 60 degree, F cos 60 degree. So F cos 60 degree will be responsible for work. Okay. The work done is what? F cos 60 degree into F cos 60 degree into S into S. F cos 60 degree into S. Okay. Now this is what? This is W. This is what a W. According to question, this is what a W. Okay, work done is W. When the angle is changed from 60 degree to 30 degree, when we change the angle from 60 to 30, the force is same. Okay, force is same, not changing the force. Okay, so this angle is not 30 degree. This angle is not 30 degrees. So what is this? F cos 30 degree. Okay. So now what do you see? F cos 30, F cos 30 into S is what? W dash, new work. Okay. So basically what you are observing, ratio of work is what? Ratio of work is what? Ratio of work is what? Ratio of cos angle. Ratio of cos angle. Okay. So work is proportional to cos theta. What you see, work is proportional to cos theta. So W1 by W2 will be this. And when you put the value, so answer will come W root 3. Answer will come W root 3. Next questions we are doing. Okay. So a long roller is pulled along the horizontal surface through a distance of 20 meters by a rope with a force of 200 Newton. If the rope makes an angle of 60 degree with the vertical while pulling, the amount of work done by the pulling force is. So basically this 60-degree angle is with the vertical. 60-degree angle will be vertical. Okay, so you need to take the angle with the horizontal, that is 30 degree. You know work is what? F S cos theta. So this is what? 30 degree. So this component is what? F cos 30 degree. This component is what? F cos 30 degree, or simply you can put, take the angle of value is 30 degree. So F S cos 30 degree, when you put the value, so answer will come this one. So answer will goes to first option. So you need to take care of the value of angle. Okay, from which axis you need to take the value of angle. Okay, so here we are taking the angle with the x-axis because basically angle is given with the y-axis. So no need to take that values. Okay, if you take that value, then your value will come wrong. Okay. Next question to see a force acts on a body and displaces it in the direction. The graph shows the relation between the force and displacement. The work done by the force is. The graph is force and displacement graph. This graph is force and displacement. So basically in this question, what do? We calculate the area of this graph. Basically, this is the graph given in the question. The area of this graph will give the work. Okay, so this is force and displacement graph. So area of the graph will give the work. Area of this graph will give the work. So when you calculate the area of triangle is what? 1 by 2 base into height. You need to take care only is that this is starting from 2 meter. So now this will be what? 12 meters. So if this will start by origin, if it will start by origin, then you need to take 14. But now it's starting from 2 meters. So you need to take 12, 14 minus 2 is 12 meters. Okay. and height is already given, that is 60. So you multiply it, you will get the answer 360 joule. You'll get the answer 360 joule. So basically, when we have force and displacement graph, so we need to take the areas and basically we get the work. Okay, so answer will be 360 joule. Next questions we are moving with. Find the work done in lifting a stone of mass 10 kg. Specific gravity is 3 from the bed of a lake to a height of 6 meter in water. So this is very good questions for J point of view. So if you see the work done in lifting a stone. So what is the mass of stone? 10 kg. And from the bed of a lake to height of 6 meter. Okay. So you are going to height of up to height of 6 meter. Up to height of 6 meter from the bed of the lake, and specific gravity is 3 meter. Specific gravity is 3 meter. So then what will be work? Question asking you the work. So basically what you need to do in this question, you need to apply basically because of find the work done in lifting a stone of mass 10 kg and specific gravity is what? 3. So what do you need to apply? mg into mgh into 1 minus 1 by rd. Basically what we are doing, mgh minus mgh divided by this rd is a specific gravity, so this is relative density. Rd is relative density. So when you do that, you get the answer. So from here you will get the 392 joule. 392 joule. So in this question, because question had given you the specific gravity, so you need to consider that value. You need to consider that value. And what is the formula for a specific gravity? I hope all of you should know this concept. Okay. So what is the formula for a specific gravity? A specific gravity is what basically relative density, that is density of substance by density of water. So density of substance divided by density of water, density of water. So density of substance divided by density of water. This is basically relative density. You should know. Okay, you should know. Okay. So from here, answer is coming 392 joule. So we are moving ahead for next question. The next question, we have the amount of work done in pumping water out of a cubical vessel of height 1 meter is nearly. So when we have a cubical vessel, height is 1 meter. So what we need to do? We need to work on center of mass. Okay, so this is cubical. So this is spread all around in 3D. So you need to take care. You need to take the height from center of mass. So this total height is suppose length, breadth, and height is one. So height is one. So what is height of center of mass from the base? That is 1 by 2 meter. Okay. So for the calculation of potential energy, you need to take the values of 1 by 2 meter. So in this question, now its question becomes very easy. So work done is what mgs, and in place of mass, you can say density into volume, density in volume. And this is your shifting center of mass. This is 1 by 2. You will do it. So you will get answer of 5,000 joule. So this is important questions and good questions. Okay. So if you understand the concept, then you can do these questions easily. Next questions we are moving ahead. We have a question of work done by the gravitational force on a body of mass m moving on a smooth horizontal surface through distance as is. Okay. So basically, gravitational force on a body of mass m moving on a smooth horizontal surface through a distance as. Question is asking you the work done. Basically, what is happening? Body is moving on horizontal surface, that is s distance, and force is acting in downward direction, that is mg. The force is acting in downward direction. Body is moving on horizontal surface. Body is moving on horizontal surface, and force is acting in downward direction. So in this case, simply what will happen? Work will be what? Zero. Work will be what? Zero, because the angle between mg and s is what? 90 degree. So from here work done will be zero. Next question we are moving. This force of 6 I cap minus 8 j cap total x on a particle and displaces it over 4 meter long the x-axis, then displaces it over 4 meter long along the y-axis, then total work done. So basically you can write this is 4 meter along x-axis. So this is this r, you can say basically what is r? 4 I cap you can say, and displace it over 4 meter long along the y-axis. You can say this is a 4 6 j cap. Basically, R is what here? 4 I cap plus of 6 j cap. So we know what is work. Work is what? F dot dr. F dot dr or F dot r. So what is what you need to do, you need to take the dot product of force and R again. You will get the value of work. So you need to take the work by doing dot product. Okay, so by doing dot product, okay, you can get the work. This is circular track of radius R in the vertical plane. AB is vertical diameter. So this AB is basically what vertical diameter. This is what vertical diameter. The work done in moving a mass along the path ACB. So along the path ACB, along the path ACB, okay, and work done in moving a mass of M. Okay, so if you move the mass M, so basically what's happening, height is you need to take care of just a height. So what will be the height in this case? Height will be 2R. So what is work done? mg2r, mg2r. Do you agree? So you need to apply the concept like this. You can get the value of work done. Basically, that is okay. Potential energy. So work done is moving the mass of this. What are the force into this question? Force is okay here, mg. So from here you can solve this question. So answer will come 2 mg r. So, for solving such questions, you need a proper okay concepts clarity. Then only you can do it. Okay. So concept clarity is very important. This tank of size, this is full of water built on the ground. Okay. And this is telling us the potential energy of the water in the tank is. So the tank of size is 10, 10, 10, 10, 10. Okay. So what do you need to do from here? You have already volume is given. So volume is what? 1000 meter cube. So this is what volume, and you know density is what 1000 kg per meter cube. Okay, 1000 okay kg per meter. So this is the density. So mass is what density into volume. Mass is what density into volume. So from here, once you get the mass, and again you need to apply the concept of center of mass because height will be uh, half of the side of the cube because center of mass will be somewhere here. We need to take care height as h by h. So h by 2. So height will be what? H by 2. So height will be h by 2 from here, and from here you can solve the questions easily. So because question is asking you the potential energy, so this you can solve it. So apply this concept, and once you apply this concept, so what you observe that okay potential energy mgh and m is what rho into volume gh. So it comes okay h is you need to take care the h of value of h is 5. Value of h is 5. So this work will be 5 into 10 to the power 7 joule. Next question we are moving with a man has twice the mass of the boy and half the kinetic energy of the boy. The ratio of speed. So basically you need to apply the ratio of half mv square. So this is good question. So you can do it easily. The ratio of kinetic energy. Once you do the ratio of kinetic energy, once you take the ratio of kinetic energy, so velocity will come in the ratio of 1:2. So you can do this question easily. No issue in it. We are moving ahead for next question. The liquid of a specific gravity 0.8 is flowing in a pipeline with a speed of 2 meter per second. Kinetic energy per cubic centimeter. Basically, kinetic energy what half mv square. Kinetic energy what half mv square. And in place of okay mv square kinetic energy. So question asking you kinetic energy per unit volume. Kinetic energy per unit volume per cubic meter means basically this you need to understand the language here. Kinetic energy per cubic meter. So per cubic meter is what? Kinetic energy per unit volume. So kinetic energy per unit volume is what? Half mv square, and divided by volume. So basically, what need to do? Half of mass per unit volume. Mass per unit volume into v square. So once you get the mass per unit volume, so what is mass per unit volume? You know a specific gravity 0.8 already given. So you need to take care the mass of 1 kg. Do you agree? So this is what you need to take care the mass of 1 kg. So you will get the value. Okay, mass of 1 means mass of 1 meter cube. Then only mass per unit volume. So take volume equals to 1 meter cube. So mass of 1 meter cube. Mass of 1 meter cube means basically density. Yes or no? So you can solve this question like this easily. So once you do, the question will come like this and this. Next questions we are moving ahead. This is the gram has a velocity. This at a certain instant its kinetic energy. So basically kinetic energy what half mv square, half mv square. So in this such questions, what we do also you can do half mv square. So velocity is dot product of 2 I cap plus 6 j cap dot of 2 I cap plus 6 j cap. This is dot. Basically what dot. So are you getting my point? So this is you need to take dot product velocity square half mv square in place of half mv. So what is this half mv dot v? Basically, this is what dot product of velocity with velocity. Because this is dot product of velocity with velocity, and this solve it, you will get 3 joule of answer. So next question we are moving ahead. Two sphere of different materials are in motion. If their densities are in the ratio this and radii in the ratio this, velocity in the ratio this, then kinetic energy. Again, you can do this question easily. Okay, so kinetic energy is what half mv square. So density okay equals to what mass is what density into volume. Mass is what density into volume. So you can take the ratio like this. So you will get the ratio from here is what 1/4. So answer will come 1/4. Next question we are moving ahead. A body is thrown at an angle of 30 degrees with the horizontal with kinetic energy 40 joule. At the highest point of its motion, kinetic energy will be. So initially kinetic energy is what 40 joules. So body is throwing by the angle of 30 degrees with the horizontal. So what is kinetic energy? Initially the body is throwing by the speed something u. But if I will ask you what is kinetic energy at the top when this projectile will reach here. So here speed will be what u cos theta or u cos 30 degree. Yes or no? This value is going to be constant velocity in x direction, in horizontal direction. There is no velocity in y direction. So basically what is kinetic energy? Half mv square. In place of velocity square, you will come, it will come u cos 30 degree ka square. U cos 30 degree ka square. You solve it, you can get the values. So basically, you need to apply the concept that at highest point kinetic energy is constant. At highest point kinetic energy is speed is what you cos theta. So you put the values and you will get the answer. You put the value, you will get the answer. This is because initially question already given you that half mu square is E, half mu square. Initially, half mu square, so half mu square is energy that is kinetic energy. That is kinetic energy. So half mu square is energy that is kinetic energy. So this way you can solve the questions and when a man running on a level ground increases his speed by 4 meters per second, if its kinetic energy increases by 125%, his initial velocity. So kinetic energy basically increases by 125 means basically you need to consider 100 plus 125. This is what 225%. So this is the kinetic energy. 225% is the kinetic energy. His initial velocity is, so this is new kinetic energy. Basically, new kinetic energy is 2.25 times of kinetic energy and initial kinetic energy, kinetic energy. You can think like this. And once you think like this, you can get the values. So kinetic energy is half mv square. So kinetic energy is velocity of ratio square. And question is saying you the velocity increases by 4, v1 plus 4. Initially velocity is v1, now velocity is v1 plus of 4 square, and this is the ratio of kinetic energy. So from here you can get the values of v1 easily. You can solve the values. So from here v1 will become 8 meter per second. So from here v1 will come 8 meter per second. Next questions we are moving ahead. An object is acted on a retarding force of 10 Newton at a particular instant. Kinetic energy 6 joule. The object will come to rest after it has traveled a distance of. So basically what is happening in this question, object is acted by retarding force. We are applying the force of 10 Newton at a particular instance. Kinetic energy 6 joule. The object will come to rest after it has traveled a distance of. Okay. So basically you need to apply here work energy theorem. So what do you say? Work energy theorem is what do you say? Object is retarding force of 10 Newton. Basically you are applying the force of 10 Newton at a particular instant and object will come to rest after it travel a distance. So work, what is work? F into D, basically work is what? F into D, and at the time, particular instant kinetic energy 6 joule. Or this work is what? Change in kinetic energy. You can say directly also half mv square. Half mv square is directly given you in the question, that is equals to 6 joule. Once you do the work done equals to 6 joule, from here you can find out the value of D easily. From here, you can find out the value of D easily. So so you solve it, so you get the value like 3 by 5 of meter. Next question, we are moving ahead. If the mass of body is reduced half, speed is double, the percentage increase in kinetic energy. You can do this question easily. Basically, apply kinetic energy formula for kinetic energy half mv square, and from here, if you take the ratio and all, so this answer will come twice. Okay, means it basically what increases by 100%. Okay, so percentage increases is 100%. Okay. Next question, we are moving with a body starts from rest and acted by a constant force. The ratio of kinetic energy gained by it in the first 5 seconds to the gain in next 5 seconds. So basically, what is question is asking you? Body is starting from rest. Starting from rest. Initial speed is zero, and after that there will be some velocity. So question is saying you the kinetic energy gain in the first 5 seconds. This is first 5 seconds. So first 5 second kinetic energy gain is what half. Okay, mv square. Okay, so half mv square. Next question is saying you in next 5 seconds kinetics there will be some next 5 seconds there will be some kinetic energy gain. Again there will be some kinetic energy gain. So question is asking you the okay next 5 seconds. Okay, first 5 seconds is that gain in the next 5 seconds. Okay. So question is asking you the ratio of this. Okay. The ratio of this kinetic energy gains. If you see kinetic energy half mv square. So from here basically what's happening? Kinetic energy what by constant you are applying some force. Constant force means constant acceleration. So from your constant acceleration, you need to understand this one constant acceleration. Constant acceleration means velocity will be what? B equals to AT. Once you put the value of velocity at any moment, okay, so kinetic energy will become a square of T square. So kinetic energy will come a square of T square. Square of T square. Square of T square. Okay, so from here kinetic energy will be what? 1 is to 3. 1 is to 3. 1 is to 3. Okay, so okay. Uniform meter scale of mass 2 kg suspended from one end, and if it's displaced through angle of 60 degree. So this increase in potential. So basically what's happening, this is suppose any bob is here, the length is L, and when it's come to some angle theta, so this bob will be something like this. Length is again L here. But if you take the projection of this, so this projection of this L in terms of height, so this will be what? If this is L, so can I say this is what? L cos theta? L cos theta, yes or no? So you, if you solve it, it will become L cos theta. Okay. So what is height? What is height? L minus L cos theta. L minus L cos theta. What is the height from here to here? What is the gain in height? What is gain in height? L minus L cos theta. So by this way, if you, I'm giving the option first here, so I solve it. So answer will come. Okay. Basically, answer will come what? This one. Okay. 4.9 of Joule. Okay. So basically what's happening here, you can take one more thing here is that, okay, what I'm saying you, that, okay, uniform meter scale, it's a meter scale. So if it is meter scale, so the mass will be uniformly distributed because meter scale is very high mass, high mass. So its center of mass will be here, somewhere here. That's why I'm taking the value L by 2 because its total length is L, so it's height L by 2. So you need to play with L by 2 only. Okay, that's what. In this, if you take L common, 1 minus cos theta, it will come 1 minus cos theta. If you take L for common from here, it will come 1 minus cos theta. 1 minus cos theta, no problem in it. But we are considering the value L by 2. Why? Because this center of mass will be here. So you need to take the length from here. So that's why it's okay meter scale. So this is a bob, normal bob. This is pendulum. This is pendulum, and this is meter scale. This is meter scale. Agree? Next questions we have. When a spring is compressed by 3 centimeter, the potential energy stored in it is U. When it is compressed further by 3 centimeter, the increased potential energy is. So basically, increased potential energy what? Half kx square. So when you will further increase, so final extension will be what? 3 plus 3, 6. Yes or no? So 6 means 36 will come over here. So if you take the ratio, it will come 4 times. So this time, so if you want to take the ratio, increase in potential energy, so increase will be for U2 minus U1 is 3 times of U. It's a good question. You can do it if you have a certain understanding of basics and okay, if you know the basic level of J-Men's level, you can easily do the questions. But if you didn't touch the levels, then you can't do the questions. Okay. So body of mass 5 kg is at rest is acted upon by two mutually perpendicular forces. Simultaneous kinetic energy after 10 seconds is. So we are applying mutually forces 6 Newton, 8 Newton. Simultaneous kinetic energy after 10 seconds is. Basically kinetic energy what half mv square. Kinetic energy what half mv square. So we are applying the force 6 square plus 8 square root 10. So from here we can get acceleration. So acceleration will come what? Acceleration is force by mass. This will come 2. Acceleration will come 2. So now we need to find out what? Okay, we need to find out velocity because we want velocity. Then only we can do kinetic energy. So kinetic energy what? Half mv square, half mv square. So this is what half and velocity is what 80 square 80 square velocity is what 80 square. So you put the values, you will get the answer from here. Okay, you put the values, you will get the answer from here. So all values I'm putting here, so our answer is coming 1000 joule, 1000 of joule. Next questions we are moving ahead. Okay, a boy is swinging on a swing such that his lowest and highest positions are at height of 2 meter and 4.5 meter respectively. His velocity at the lowest position is. Okay. So big boy is swinging on a swing such that his lowest and highest positions are at a height of lowest position is at the height of 2 meter and highest position is at the height of 4.5 meter. So from here basically what you need to do, change in potential energy. So change in potential H1 minus H2, H1 minus H2. So from once you do H1 minus H2, you will get change in potential energy. Once you get change in potential energy, this is equal to change half mv square, that is kinetic energy. So from here, once you get kinetic energy half mv square, so easily you can get the velocity here. Okay, so basically you need to know the concepts that kinetic energy or change in potential energy. So this will come 7 meter per second. Next question, we are moving ahead. At what height above the ground must a mass of 5 kg to be have its potential energy equal in value to the kinetic energy of possessed by it when it moves with a velocity of 10 meter per second? It's easy question again. Kinetic energy will be what potential energy. Kinetic energy equals to potential energy. This is from here. If you solve it, so it will come u square by 2g. Put the values, you will get the answer. So next question we are doing with okay, AB friction inclined surface, AB friction inclined surface, frictionless inclined surface, making angle of 30 degree with the horizontal. A is 6.3 meter above the ground, B is 3.8 meter above the ground. A block slides from down from A. So the block is sliding from A. Block is sliding from A. Block is sliding from A. So initially starting from rest, its velocity of reaching B. So you have two, three advantage here is that surface is frictionless. So surface is frictionless, surface is frictionless. Okay, if the surface is frictionless, so then what do you see? What do you see? Okay, 6.3 meter. Okay, 6.3 meter and 3.8 meter. Okay, 6.3 meter and 8 meter. This angle is what 30 degree. Yes or no? So basically, what is happening? Question asking you velocity. So velocity, what change in potential energy. So once you get the change in potential energy, what how much of gain you are gaining the potential energy, that will be equals to velocity. So you know you will solve these relations, you will get this relation formula velocity equals to root 2 GL sine theta. So you should know this concept. Okay, that velocity is square root of 2 GL sine theta. Otherwise, you can drive it no issue because L sine theta will come H. Okay. So this velocity is root 2 GH. Basically, velocity will come if some no friction, velocity is root 2 GH. Velocity is root 2 GH. You will apply this relation and H is what has 2 minus H1. H is what has 2 minus H1. So this is good question. So once you know, you can solve it. So you can get the values. So I'm solving here. So after solving, answer is coming 7 meter per second.